MC.
Hi, everyone. Thank you so much for your time and for joining this webinar series. Before we officially begin, I just wanted to provide a couple of just warm greetings and welcome remarks. First and foremost, thank you so much for carving out time for this presentation. I'm really excited to have the ability to speak to everyone, and also wanted to give special thanks to, of course, you as the audience for joining this webinar, and Jason and Shriram from our team to putting it together, this webinar series. Not only am I excited to give this talk today, but also for the up and coming webinars that we have on other topics regarding performance and automation. So for today, we're going to focus on improving your mobile app quality through performance testing. This is a topic near and dear to me, so I'm really excited for us to jump into this together. That being said, we're going to sort of wait a little bit here for a couple more people to trickle in. So that being said, we'll go ahead and join momentarily and stay tuned. So that being said, we'll go ahead and begin at 2:05 p.m. So that's coming up very shortly. Okay, excellent. So now it's 2:05. So in terms of agenda, I think we should totally get started. And as people trickle in, we can start to formulate questions. So that being said, we're utilizing GoToWebinar, which is a built-in Q&A panel. So at any time that you have questions, feel free to jump in your questions in the session. And when we get to the Q&A portion, we can get into it. So that being said, I'm really excited to jump into the material that we presented for today. So that being said, I wanted to first start off with an introduction on why performance matters. From there, we'll go ahead and jump into actually HeadSpin performance sessions. We'll walk you through the tool that we've built and a couple of really critical examples and of ways to use a tool to improve your application. That being said, we'll also talk about common client-server performance issues, some strategies around that, and also at the end have time for Q&A so we can answer your really excellent questions. So that being said, why does performance matter? Well, I think on the screen we can all relate to this in the sense that we've all experienced both good and bad user experiences before. And performance can mean a lot of different things to different people. But when it comes to mobile applications, performance really describes how efficiently your application works and how effectively and enjoyable the app was to use. And from a developer perspective, sometimes you're just very excited when you just get your app to run across all of your top targeted devices. That feels like an accomplishment of its own. But that being said, in this presentation, we'll dig a little bit deeper into this, and we'll talk about performance considerations, how to make it run well on all devices, not just the top targeted devices, giving every user an ultimate experience for your application. So that being said, the first consideration we have for performance is user engagement. So that being said, human engagement studies going all the way back to 1960s have shown that actions that take under 100 milliseconds are perceived to be instant, where actions that take a second or longer basically cause the human mind to be distracted. So these delays and slowness in your application, and even if it's just the perception of slowness, is one of the biggest killers of app engagement out there. A second really important consideration is sales and in-app purchases in your application. So I wanted to discuss this with a hypothetical example. So let's say that you're working on an app with an e-commerce component, and your growth team has collected analytics showing that the average shopping session is 5 minutes long, that each product in the item UI view takes 10 seconds to load, and that it takes 30 views on average to complete a sale. So if you were to reduce the load time of loading each product UI view by just 1 second, you've now allowed for 3 additional screen views of product items to load in an average session. So therefore, this could allow your customers to add more items to their shopping cart, or perhaps just complete the entire transaction 30 seconds faster. In other words, performance really correlates to, for example, transactions that can occur. And then another important consideration is the infrastructure and how much you can save with optimal performance. As we all know, mobile applications download a lot of content from remote servers, and lowering the number of requests or reducing the size of each request can yield huge speed improvements inside your application, and will also yield in huge reductions of the traffic on your backend, allowing you to grow your infrastructure at the pace that's less expensive. So that being said, I wanted to jump into HeadSpin performance sessions. It's a tool that we've built to allow you to explore and understand your app's network characteristics. And what's really powerful and interesting about this is that we actually, you can conduct a HeadSpin performance sessions via a remote control session. So that's a manual session on the platform where it's very, very cool. You can actually use a real Android and iOS device from the comfort of your web browser. You can also trigger it via automation tests, whether that's an Appium test, Express test, or XCUI test. And that being said, we capture all of the network traffic from the cell interface, the video of the test session, client server data, and client data. And this gets fed into our AI-based issue detection engine that will generate a dashboard. And I wanted to walk through what this looks like and how you can use HeadSpin performance sessions to make improvements in your app and improve the overall user experience. So that being said, before I jump into the tool, I wanted to give a quick lay of the land. So we're going to be focusing on the waterfall UI for this session, and I wanted to give you a walkthrough of how to understand like the UI of the tool. So what I did was I actually pulled up a performance session so we can walk through this together. So that being said, I wanted to first talk about the 6 sections of the UI. So I'll start from left to right here. So this is the project info panel it shows you where the test was conducted and all of the underlying data from the test session. What we have in the middle here is the metrics graph column, which I'll actually jump into in a second. What we have here is actually a live video. This is the video from the test session. And as I scroll through the waterfall, you'll see that it actually correlates to, like the data correlates to what the video was during the test execution. And then if I go to my left-hand side here, now that I've scrolled down, you can see our issues palette. So any issues that our platform engine detects, it'll generate an issue card, show you how many issues there were, so it'll group it, and you're told in plain English what the issue is and suggestions on how to fix it. And we'll talk about common issues momentarily. And then we get to the network timeline, which is really great, overlay of time series data as well as the network transactions. And then we have the detail palette. So you can actually click on a given like a artifact in this timeline view and understand the requests and response headers. And this is very, very crucial for debugging and understanding performance of your application on a real network. And we'll actually talk about this momentarily as well. So that being said, I just wanted to give a quick introduction to the metrics panel up here, because this is very, very crucial in terms of, think of it as like your heads-up display, if you will, before you jump into the data. So that being said, in terms of metrics graphs, they're really great because they provide the sums and averages of different types of network data captured during a session. So for example, answering questions such as the total number of HTTP requests, the average download speed, so on and so forth. And that being said, we calculate the metrics on 4 groups of requests. So the first one is session-wide. This is your bird's eye view. This is for every network message in a session. And then we can jump into the domain view. So this is every message sent to or received to from a specific domain. From there, we can actually jump into the host metrics. So this is every message sent to or received from a particular host. And then we have a really important HeadSpin measurement that we've designed called the burst metrics. And this is every message in an area of continuous network activity. And that being said, to summarize the data that we're looking at here, so you'll see that there's an average wait. So for a given, for example, in this case, domain, because I'm in this section, we can actually see what's the average wait time that spent for a response from the server. From there, we can actually discern what the traffic is, the total amount of data transferred between the server and in the point of presence. And then from there, the download speed, so the average rate of data transfer, and then the number of requests that were made. What's really cool is that we also show visualizations on the traffic content. So for example, this pie graph shows you the proportion of what your application receives in terms of different data types. So we can see, for example, there's a lot of JSON, like in a particular request. And also, if I go ahead and click more here, it'll actually reveal more visualizations, which can be really helpful to discern other items, such as, for example, the number of connections being made, new, reuse, status codes, so 200, 300, 400, 500, etc. And just to jump back into the traffic content, this is really great because a couple of considerations here are essentially, is your application receiving any unexpected content? And in summary here, with the pie charts, we can actually examine where the particular content was coming from. Another thing that I do want to note here is that you notice that there's like this visualization in terms of this is color coordinated, and the orange color, this is the time to spend opening new TCP connections. The purple is the encryption time, so this is the time spent performing the TLS handshakes, for example, preparing to communicate securely over HTTPS. Green is the time spent sending a request and receiving the first byte of the response, and then blue is the time spent receiving a server's response. That being said, if I scroll down here and jumping back to like the waterfall layout here, what's really powerful is that we have these AI issue cards that automatically get generated for any deficiencies or potential issues that can occur over the network. And for example, as you can see from this session, we've identified, for example, areas of low page content. So if I hover over these orange areas, as you can see, the platform tells me what the impact time is. You can see that this was like an asynchronous state with the filter. We can see that there's a spinner, and we can see the impact time. That being said, there's also a classifier exclusively for loading animations, which is super cool for detecting, once again, these UI UX states that are questionable that we should sort of focus on to understand better, as well as for other really important issues, such as, for example, what were the slow servers during this session? And furthermore, what downloads took a long time? Well, and what made them slow? So as you can see with the waterfall UI, this gives you powerful tooling to answer questions that otherwise you wouldn't be able to answer, in the sense that, typically speaking, people, when they're testing, or for that being said, developing their applications, they're developing it on emulator simulators, so first of all, not on a real device, and in office broadband, so not commensurate to the entropy and chaos that can occur over the network. And we'll actually talk about some common issues as well that can occur over the network. So that being said, to jump back into our presentation here, we talked about, for example, the waterfall UI, the structure of the different UI components, and a cursory overview, essentially, using the UI and the type of issues. And that being said, I wanted to talk about some discrete use cases and some common things that we've seen in terms of analyzing applications using HeadSpin performance sessions. So that being said, we spoke with a lot of our customers, and this is from our work, but also feedback that we've gotten from customers. A couple of top things that I wanted to note and share in this session. And then I'll show you real examples of how you can identify this in a HeadSpin performance session. So that being said, the first one is that I want to talk about how we can improve slow downloads, because that's a common question that we get. And also, hand in hand with slow downloads, how do we prevent duplicate messages from occurring, or even detecting that, for that matter? So first and foremost, if your application has a lot of images, as most applications do, and these images are, of course, downloaded over the network, you want to consider having the server-side ability to configure the height and width parameters through URL query parameters. So, for example, if I jump into this session here, so this is an Airbnb session conducted in Sao Paulo, Brazil. And all the examples that we have prepared today, they're international examples to give you a sense of globalization and the breadth in terms of where your users are globally distributed, and how you can improve things from a global mindset. So that being said here, if I go ahead and click on slow downloads, and I scroll down here, we can see that, for example, the platform has detected some slow downloads coming from this particular domain, which is actually a CDN. So that being said, if I click on this request, I can see it's a GET request. And if I click on the request headers, I can see what the client request headers were. We can see that there's GZIP, which is good. And we'll actually talk about GZIP in this presentation. And also the response headers back from the server. You can actually see that, for example, it's an Nginx server. We can see that it's a JPEG. This is a GET request. And then there are, and because it's a JPEG, and it's a GET request, we can actually just copy this URL. And I'll go ahead and actually paste it in my browser. And going back to this clear string parameter, we can actually see that this image is quite large. So we can see that, like, for example, if I click zoom, it's not even, it's sort of over the bounds, if you will, of my default port view here in my browser. And it's a pretty big image. And as you can imagine, for big images, the client actually, now the responsibility falls on it to actually resize this, which of course takes computation that has to be from the client side. And that being said, for example, we can see from the URL actually that there are query string parameters. So I think this is an interesting example to show that if you have query string parameters, one thing that you can do to actually improve the user experience is to actually, for example, and we'll actually talk about some of these strategies as well later in this presentation, is use it to essentially, based on the device type or the network information that you can discern, actually use this to resize it from the server side. In other words, with query string parameters, you can create flexibility such that you can actually resize the image. You can request like a certain size of it, such that the burden of resizing this image doesn't fall on the client side. So this is an interesting example because like we can see from the URL that there are query string parameters, and if utilized, could have made this download actually much less. We can see that there's an impact time of over 1 second to download this. And if the query string parameters were used such that it returned the width and height of the image already pre-filled to something that's commensurate to this device's screen resolution, pixel density, it could have lessened this impact time that we can see to download this information. So that's one consideration. That being said, like going hand in hand, don't download images larger than the device resolution. And that being said, in terms of a couple of examples here, is that, for example, a shopping app. And shopping apps, of course, have a lot of product detailed views. So we can see there's a lot of GET requests to actually get images and content. So for example, once again, it's a GET request. I'll go ahead and copy and paste it in my browser here. And we can see that once again, it's a very big image. And this just goes hand in hand with the previous point where you want to avoid downloading images that are larger than device resolution, or else you make that burden fall onto the client side. And then another consideration, especially regarding images, since they're so prolific, is that our personal recommendation is to perform lossless image compression, whether it's PNG or JPEG images, or even better, we highly recommend giving a try the WebP image format. Google has like popularized this in recent years. It's a very good web standard for images because it's a nice balance between the compression but also image quality. In other words, like high fidelity images at a smaller file size, which is great. So less file size, less time spent downloading. And then another considerations for improving slide downloads, like let's say that you have interactive content. So let's say you have video content, streaming video. We recommend making making the downloads for these resumable. And this is something you can implement by specifying the content range header, which will prevent against duplicate copies being downloaded. So for example, here is a streaming video example. So once again, this is a cool global example. So this is actually a Tencent video stream on a device in Bangkok, Thailand. And in similar fashion, if I go ahead and click on slow downloads here, and I scroll all the way down, we can see the platform's automatically identified these slow download streams. And what's interesting is that we can see that this video is chopped up, so it's partial content. We can see that there is a cache control applied, which is good. We'll talk a bit more of that as well. And essentially, we can see that there is a content range header. And the reason why this is very good is because like once again, like you want especially for big things like videos or even big images, like you don't want to have the client to have to like re-download it if possible. And we'll also talk about caching strategies in this presentation as well. So that's once again an example of specifying that content range header to prevent against duplicate copies being downloaded. And that being said, depending on the network that your customer connects to, the application user experience could be completely different. So that being said, at HeadSpin, because we have devices all over the world that are carrier activated, so real Android and iOS devices on carrier activated SIMs, this gives you the ability as a developer to actually understand how your application performs in different network conditions. Like as we all know, the download speed and latency really depends on the network subtype. And as a good example of this is that in the platform, we automatically, of course, like detect these issues. And sort of hand in hand with a video stream here is that we'll automatically detect for example, the frame rate, but also frame freezes. So the perception of like, for example, this user experience like freezing. I wanted to make note of this because like if you have a very like interactive, rich user experience, you don't want, for example, network to be the bottleneck for you to deliver what you need to the client. So I wanted to first and foremost like make note that the network matters. So as a result, being able to test your application across different devices and different networks is really important, which you can do in HeadSpin. So that being said, I want to talk about ways for you to make network optimizations. Wanted to just start off with a rule of thumb in terms of top things that you can do to make improvements. First and foremost, aim to make fewer HTTP requests if possible. And the mantra here is do as much as you can with less. The second is using a content delivery network because things such as, for example, the querying parameter to resize images, and especially, of course, like the hop in terms of like where the content is being fetched to. There's a lot. It's just a lot easier with a CDN. This is one of those things where it's a quick win for your assets. Another consideration is compressing the traffic with gzip, and we're actually going to talk about that a bit more in terms of file optimizations. Once again, from a network side, again, reducing the number of DNS like lookups. That being said, every DNS lookup has an expense in terms of the TLS handshakes that need to be made, and then avoiding redirects. And what's really powerful about our platform is that these are all things that you can validate and discern from a HeadSpin performance session. So that being said, I wanted to focus on things that you can do to optimize the files over network. So that being said, there are essentially two basic ways to download data faster. One is that you can lower the number of requests, or you can actually reduce the number, or I should say, rather, the size of those requests. In terms of lowering the number of requests, what's really handy is that, once again, in the HeadSpin performance session tool, and this can be validated from the pie graphs that are generated, you can actually see, in terms of connections usage, the number of requests made, and then from there, how many were new, how many were reviews. So that's really important. And that being said, you can also like do things to reduce the size of those requests. And for example, in the screenshot, we're taking a look at the gzip content. And that being said, let me explain this a bit further. So when you're delivering text content, for example, JSON, HTML, CSS, JavaScript, using gzip, you can actually compress them on the server and then deliver it to the application. So as we all know, smaller file size means fewer round trips and a faster delivery. And for users or for for example, if you have a hybrid application or a mobile responsive website, certainly consider, just like as you would want to do on the desktop, that guidance holds true in the sense that you certainly want to ensure that you're minifying JavaScript and CSS. And then that said, we talked about this earlier and just wanted to reinforce this is, of course, image compression. So for images, like compression on the PNGs, JPEG, and also consider using the WebP format. And that being said, another way to optimize things from a file perspective is implementing file caching. So file caching is really great because it can help save mobile data usage. So great for users, but also for their battery as well. That being said, I want to talk through important considerations from both the client and server side. So for example, on the client side, you want to download files that are used frequently and then store them locally for reuse. The mantra here is download once and use multiple times. That being said, to the extent that you can actually download, either store or just cache things that are common, come up frequently, that's less time spent downloading, and the whole process that entails. And that being said, you can also cache from the server side. So for example, by setting a server caching content policy, you can ensure that customers receive up-to-date data, but also limit the number of files that are downloaded duplicatively. So what's really powerful once again about HeadSpin platform is that these are all things that we can determine. For example, just to go back to just like perhaps this example here is that here we have the ability to just to recap, take a look at what the slow downloads are and see what the request and response header is like, and actually validate the URL that was constructed from your code in terms of the request that was made. From there, we can also, for example, take a look at any HTTP redirects, and common things that we see in terms of redirects are actually can be caused by third-party SDKs that you're using or embedded in your application. This can be, of course, really costly if you think of it from a global perspective. And let's say that you are an application that's in Hong Kong, but you're using SDKs that beacon out to domains or IPs in North America. Or fallbacks between HTTP and HTTPS. So these are things that the platform exposes that you can actually take action on. And also too, to see failed transactions. So for example, HTTP errors. And what's really cool is that we can actually view this data. We have the ability to, of course, export data shown up earlier. If you just want the data from that card, you can actually download it from this CSV button, or you can view it in a tabular format, which is really handy, which I utilize often. And that being said, we're looking at all the HTTP errors that occur here. So for example, we can see that there were requests made from the application and also from SDKs that they're using that actually errored out. So it was a 400 bad request. And that being said, of course, HTTP errors not only incur the cost of making that request, but then the content actually never comes back to the client. So that being said, there's a dedicated issue card for just quickly identifying in a given session what were those errors. And another very important consideration is unencrypted traffic. So this is a security consideration, of course. And that being said, you don't want us to transmit data that's, of course, sensitive in any means from an unencrypted connection. So that being said, we automatically have a flag for detecting things that are sent via HTTP, such that you are aware of it and know if you need to take action, based on the URL and what method is being performed for the given action. So that being said, I want to talk about some performance strategies. So that being said, the benefit, of course, testing on real devices on a real network is that you can learn what your performance is like. And that being said, we've talked about some considerations, issues, and pitfalls in this presentation. And that being said, now that you know this information, you can take action. In other words, just having the ability to use, for example, HeadSpin performance sessions to get this information, no matter where you stand in terms of your current application performance, what's great is that having data, you can take action upon it. You can make things better. And we put together a couple of strategies here in terms of how you can make your application perform better. So first and foremost, making your app aware of the network that it's on. So that being said, on the Android and iOS platform, you can, for example, query the connectivity managers to check to see if it's on Wi-Fi or a cellular connection. And that being said, if the user is on a cellular connection, you can defer non-urgent communication until they are on Wi-Fi, which is really helpful. That being said, another strategy that you can utilize here about making your app aware of the network is to deliver content and features potentially based on the user's connection. So for example, if the user is on a slow network, or if we really had to simplify it, since Wi-Fi represents the best condition that a user can be on, and cellular, of course, is going to be more chaotic. And as shown from the table earlier, of course, different speeds, latencies. But for example, if you're on a slow network, you could, for example, provide smaller images. And bonus points if, for example, you have a query string parameter that allows for the image to be resized on the server side, because essentially you can just do a check to see is user on Wi-Fi or cellular, and if so, give images or other content that's commensurate to their network speed. And in terms of video, if you have a video component or application, this is great too in terms of making the streaming adaptive based on the connection that the user has. And also, depending on the features of your application, you can also considering now that if you make your app network aware, to also show features based on the network type that the user is on, such that you only, for example, could provide them with features that would work well under like a lower network performance or subtype, and give them more features when they're on a better network. Another consideration for making your app aware of the network is that you can now account for network latency by prefetching content. So to give a concrete example of this, let's say that you have an image list or table view, depending if this is Android or iOS, in your application, and you can initiate a prefetch on this image list or table view, such that there is either data on the initial view, so you can prefetch before the segue to that view, or, for example, doing a prefetch as the user scrolls or flicking through, and they're approaching the end of the list. And the idea here is by utilizing prefetching, you can actually, it's a lot of great benefits here, but the two wins here is that, one, just from a visual user perspective, they at least see content. So they see content, so it just overall feels like a more full, a more rich user experience. But also too is that by prefetching, you can also ensure that you're making the appropriate network requests in a manner that will still make it fluid, like a fluid experience as well. And like one of the takeaways from using this strategy is that it's really cool because now you can combat latency. So if you're in a high latency environment, you could prefetch more images. So when a user scrolls to the beginning or end of the list, there's still content. And a visual example of this is that a lot of applications. So like for example, this is Apple Music, but of course a lot of applications that we all use, know, and love have a list or table view component that has a detailed image view or detailed image cell. And that being said, using these strategies, you can actually prevent these type of states, such that you see, for example, like the placeholder images, or in this case, like an async state where you see gray placeholders for, in this case, album or artist thumbnails. And once again, the beauty of the HeadSpin platform is that using performance sessions, you can actually not only see where these visual areas are in your application, but then also tie it back to what requests are being made. So for example, in this, on the slide, we can see that this was a GET request for an image thumbnail. We can see what the responses are. So you can actually dig deep into understanding what the requests are. And that being said, I wanted to give us the opportunity to now open up to Q&A because first and foremost, just very thankful for everyone on the virtual bridge for joining the presentation, and wanted to give the ability for us to pause here, understand what the questions are from the audience, and then also with the time remaining, talk through a couple of really other cool features with performance sessions. With that being said, just wanted to once again express thanks. And then at this point, we'll go ahead and take a look at, for example, like the questions that are being asked on the webinar. So that being said, you can actually use the go-to webinar tool to answer questions. So in the widget panel here, there's a questions column, and you have the ability to actually type answers here. Or if you'd like to, if you want to make it more private, you can actually even send an individual chat message to me via the chat tool. Okay, great. So, I'm starting to see questions flood in here. So, the first question, really great question, and I'll read it verbatim. So, from your experience, what's the number one driver of poor app performance? So that's a really great question. So that being said, there are many things that could, of course, cause poor app performance. But especially in light of the theme for today is certainly network, because as we discussed, network can be a black box, because from a developer perspective, how do you understand how your application is performing on different network subtypes like 3G, HSPA+, LTE? And that's why at HeadSpin, we're providing not only the infrastructure to actually test, but deep analytics on understanding the performance. And that being said, going back to just a recommendation list, I would say that the number one thing that you should certainly consider, I'll go ahead actually and put this up here, is duplicate messages. So we observe this where a lot of sort of default strategies that people use is that they'll make multiple requests if a request is not fulfilled in a certain amount of time. And that being said, as a result, what we end up seeing is that we see duplicate messages in the session, such that the application is receiving identical copies of these resources. So for example, in the screenshot, this was actually a top shopping app. And we were seeing, for example, a lot of duplicate requests being made and then fulfilled by the client on a 3G connection versus an LTE connection. So that being said, in terms of number one driver, certainly understanding and being adaptive, and for example, using some of these strategies discussed today to make your application aware of the network, so you can guard against these type of conditions from happening. And then another question that we got is essentially understanding the issue cards. So that's a really great question. I'll go ahead and actually jump back into the performance session UI. So that being said, these issue cards are dynamic. Based on the data shape the traffic, these will get generated, which is really great. What's cool about the issue cards, and I'll talk about a pipeline of how you can think about these, is that essentially, in terms of the issue cards, it gives you a good way to filter and understand where to focus first. So personally for me, I like to start with areas of low page content because they represent incomplete states of the application. So for example, if I click on the issue card, I'll visually be shown, for example, essentially the state. I can visually see it on the right-hand side, but also too with the tooltip, I can see what the impact time is. And for example, if I go ahead and zoom out and press zoom to fit, we can see actually multiple regions of this, which is really great. And that being said, I like to start with these areas of low page content or loading animation because they represent, of course, like areas that can be improved. And that being said, from there, I like to actually jump into, for example, taking a look at any slow downloads and see if they are intersect with these areas or are near, as you can see, things concurrently cross-cutting through these regions. And then from there, I like to just dig into the request and response headers to help to understand essentially, was this request constructed correctly, first and foremost, and then also to see, for example, if I scroll down here, this is the response. And of course, taking a look to see what was the status code was very important, but then also talking earlier about these caching strategies, especially in this case from like understanding and if you want to understand or test your caching strategies from server side. So that's how I like to triage through these data sets. And that being said, to sort of tie things end to end is that what's really cool is that we have a capability in the platform called continuous monitoring. And what it allows you to do is that it allows you to actually bucketize these discrete performance sessions, put them into, like, we could say, a virtual folder, and then from there, actually visualize on the aggregate. For example, like all your performance sessions, which will be represented by these dots here across different devices and different geographical regions across all of the measurements in the HeadSpin platform. In addition, we have an API for you to post your own measurements. For example, if you're running let's say like an Appium script or just an automation script in general and want to like calculate a metric during that test. And then from there, we actually have this very, very cool feature called the Replica Database feature that actually will generate a copy of you, a database copy for you to actually query and understand deeper. In other words, all of the data, all the metrics from your performance sessions are just like a SQL query away from like answering custom questions that you might have based on this data set. But also, for example, visualize this in tools such as Grafana or Tableau or Google Data Studio. So for example, like using this feature, you can actually construct really great dashboards. So I want to show you, for example, a Grafana dashboard, for example, of social media apps that we're tracking to understand, for example, performance. So as you can see here, for example, we're tracking critical UI flows and KPIs, so key performance indicators for, as an example, Instagram. So taking a look at, for example, what's the login time of Instagram across the different carriers in North America, in the United States, and across operating systems. So for example, on Android versus iOS, and the login time in the case for Instagram, the upload time, understanding what's the experience of LinkedIn, understanding Snapchat, popular, once again, social media applications, such as TikTok, Twitter. So that being said, you can actually start to create these dashboards and actually monitor the performance of your application over time, build after build, and also use this feature to actually query this data set in SQL format to answer custom questions that you might have. So what's really cool is that from an end-to-end perspective, you have the ability to actually not only use the platform to collect data on real devices on different carrier networks worldwide, but then use HeadSpin performance sessions to understand what the performance is like from a client server perspective. And then from there, actually, you take action upon this data in the sense that you can actually, like for example, the database feature mentioned, actually query this data and also generate these type of visualizations for your organization as well. So you can understand the operations of how your app is performing build in, for example, different parts of the world, or in this case, different carriers. So it allows you to understand the narrative of your application performance. So that being said, if there are more questions that you might have, feel free to either, of course, go to our website, or you can actually email me directly. So I went ahead and I put my email address here in the slides. And in terms of a couple of concluding remarks here, is that I wanted to first and foremost thank everyone for the time that you spent for this webinar. And we're really excited to, of course, talk through these common and important topics that we not only receive as questions, but we actually do in terms of our work working with different companies, different developers worldwide. And ultimately speaking, we want to help you build the best 5-star application experience. And that being said, performance, in order to better understand it, of course, you need, of course, great tooling. And we spent a lot of time to make HeadSpin performance sessions something that can help you find and fix these issues such that your users don't see them. Like once you have that final release and it's pushed to the App Store. And oh, actually, we just got one other question that trickled in talking about video performance. So that being said, let me actually switch back to, for example, my browser, and I wanted to actually jump back into the session shown here actually. So this is Tencent Video, like playing on a real device in Bangkok, Thailand. And that being said, we have really cool custom time series visualizations for video content. So that being said, one that we briefly discussed earlier, but this is frame rate. So for any video that's in landscape mode, not only will frame rate be tracked, but also too, for example, these like low frame rate areas that can cause a perceptible freeze get detected, which is really phenomenal. And if I hover over this tooltip, we can see here where the time is. And that being said too, in terms of the perceptible quality of this video, we also track, for example, perceptible factors such as blurriness and blockiness. So for example, when there's in this video stream a lot of motion, you can see there's smoke in the video, we can see the blockiness and blurriness score increases, but we can also visually see that, which is really great. So validating the quality of the video content. And that being said, of course, going back to the network considerations, understanding, for example, the concurrency, the number of connections that are being made. We can see that a lot of downloads were being made in the beginning as the client was requesting these chunks of different split up data streams. But then also understand how this is affecting client performance metrics, such as, for example, the net CPU during this test session. And the memory used on the device. We can see that it's kicking up pretty high when there's a lot of this video content here. So that being said, very handy for, of course, if there's a video component in your application, understanding what's that perceptible experience and quality, and in similar fashion, being able to correlate that to what the user experience is like from the waterfall UI. And then from there, be able to make decisions based on the issue cards that you see and the actual network transactions. And that being said, for example, the slow downloads, we talk about duplicate messages, frame freezes, which we visually saw up here, and so on and so forth. So there's a lot of just really interesting issues that of course can surface and you can take action upon using performance sessions to analyze your application. So that being said, in terms of just the remaining concluding remarks on my side, once again, thank you so much, everyone, for your time today. And I really appreciate the opportunity to speak about topics that are near and dear to us, and ultimately helping you and your teams improve your application performance. That being said, if there are any other questions that you have or you anticipate coming up, feel free to shoot us an email, or in particular, shoot me an email. And happy to, of course, spend time with you to talk about, for example, performance, talk about these topics in length. There are a lot of really great, just like other additional topics in terms of performance recommendations or just the topic of performance that we'd love to talk about. And also to help you to get on board and use HeadSpin to understand your application and ultimately improve it to give you a 5-star user experience. That being said, thank you so much for your time, and also be on the lookout for the up and coming webinar topics that we have. For example, understanding the client-side performance, and also automation testing. So that being said, thank you so much, everyone, for your time, and take care, and talk to you soon.